Here's your typical SG circuit. We've taken the trigger winding and put it to the positive of a primary battery. What we have is we have multiple batteries in series connected across this power winding. Now this the circuit's no different than what everybody should be accustomed to when you're running a Bedini basically in solid state mode. The trigger winding and the power winding are roughly 12 feet long. They're wrapped on a 5/16 of an inch air coil core spool. Like I said, about 12 feet long. Your welding rods are a typical welding rod, copper welding rod, 1/16 of an inch. This is the spool, just a small tiny little spool, and we're running it at a frequency of about 35.7 kilohertz. This is the battery bank, this is the powering battery, these are your secondary batteries all connected in series. This is the voltage of your primary bank and the voltage of the secondary bank. The secondary bank is climbing slowly and this one's dropping down, you know, as we're accustomed to. So anyways, we're drawing about 1.3 amps. We're close to it. Now when we insert this rod into the core, we'll do it for about 40 seconds, or whatever. Like, it'll start to heat up enough that it'll boil well beyond 100 degrees C in not very much time at all, maybe 15 seconds or 10 seconds. But what I'm going to do is heat it up enough to change so that we can discolor the copper on the core itself, on the welding rod itself. So what we'll do is we'll run it here. Okay, we'll give it roughly about 40 seconds. And we'll just let that heat up. Eventually I'll start to feel it in my fingers there, a little bit of heat transfer. You can start to feel it now, a little bit. So it does put out some serious heat into this piece of iron. Just let her go a little longer. Okay, so you can see the rod itself is discolored. Dip it in the water. Very hot. Very hot indeed. So, you know, it's quite a discoloration. There's a fair amount of heat being generated here. And that was all at, like I said, about 1 amp, 1.2. I just have the pot adjusted a little high, so you know, I don't know what else to really say, but it's a pretty decent amount of heat transfer, that's for sure. I tried it, you know, basically without the pulses. I mean, I can tune this system so that we can basically get rid of the pulses. And, you know, so a waveform, something like this, doesn't generate the heat within the iron piece, and a waveform, you know, like that kind of doesn't generate it either. It might at higher voltages, but it doesn't do it at 12 volts, that's for sure. So we're looking for the typical solid state waveform associated with the Bedini. That seems to give the best bang for your buck when it comes to energy anyways, energy consumption versus heat. So again, what I'll do is I'll use the welding rod again, and this is a different, the other end of the rod. We'll put it back in there, We'll do it for about 40 seconds. Okay, and there's the waveform. It starts to, since the pot's not tuned quite correct, we do have an issue with kind of a secondary oscillation coming about. So if we were to increase the amperage just a little bit to get us back to just over 1 amp, you know, we would see some more heat being generated within this core here. But okay, that's roughly 40 seconds. See, it never even discolored it too much, although it's still hot. But it's that secondary isolation, or that secondary oscillation, or group of pulses that changes the frequency and causes some issues. So what we'll do is we'll turn it up again a little bit to try and combat what we're seeing there. So now we're about 1.3 amps, still running at about 34 kilohertz, and we'll try this particular welding rod, and we'll do it again for about 40 seconds. So we'll okay, there we go. So you can see the waveform. Oh, running about 35 kilohertz. Waveform seems to be steady at that amperage. Okay, 10 more seconds, roughly. Just using the timer on the camera here. Alright, you can see some discoloration there again. Very hot. Okay, so I guess that's about that for the video. Just wanted to show you that. I can also use a, I can also use a bolt or a screw in this case, machine screw. And again, the frequency, as soon as I put it in there, the frequency changes. So I'll have to adjust the pot accordingly to get rid of that. But we can't, we don't have enough on our pot to change the frequency. So I guess it still generates some heat, but not as much as we'd like. Yeah, it's quite warm to the touch. But you know, this is serious. It'll generate some pretty good heat, no doubt about it. Just for the conversation, I guess we'll just put in a thermometer in there. I don't know how accurate this really is. The thermometer is pretty accurate, but when you're putting a bimetal thermometer in a core of a magnetic field, I don't know, or a reversing magnetic field, I don't know what how accurate it really is, but nonetheless, it is climbing. And this thing is, it's a stainless thermometer on the outside, but I suspect it does have some iron on the inside because it is magnetic. So anyways, I can touch it. It's hot. Ooh. You know, it's probably 100 degrees, you know, like it says, or close to it. So anyways, it's just a short video. To show you what I've been doing. Okay, thanks for watching.